All right, Course 2 peeps. This is actually investigation number 7. I'm not going to have you do any homework for this, but you do need to watch this and you do need to understand these concepts because they will be used in the coming lessons. So, first of all, I want you to understand that the number multiplying the variable is called the coefficient. So with 3x, the coefficient is 3 because x is the variable. Okay? Coefficient, variable. Now, I also want you to remember that in algebra, we like to use balanced equations. This right here, this lovely picture of a balance, shows x plus 12 equals 33. That's balanced because I'm telling you they're equal, okay? Now, what I want to do in my equation is I want to get rid of this plus 12. I want to isolate the variable x to know what it really equals, right? So, look here. Whatever I do on one side of my balance, I must do on the other side of my balance. The way to get rid of a positive 12, if you want to think of it that way, is to add a negative 12. So positive 12 and negative 12, that would be 0, right? Ding, 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 ding. So that would isolate x. 33 minus 12 is what? Boom, 21. So x equals 21. Now, sometimes they're going to just try to trick you. They're going to put the equal sign on the wrong side. So we have 45 equals x plus 18. How do I get rid of that 18? Well, I'm going to subtract 18, right? Because I'm adding it here, so I'm going to do the opposite. I'm going to subtract 18. But whatever I do to one side of the equal sign, I must do to the other side of the equal sign. So x plus 18 minus 18 is the same as 45 minus 18. Now I've just gotten rid of this, so I've isolated my x, so x equals 45 minus 18 is 27. Okay? All right, let me show you a couple more, if I can turn the page. All right, so 2 times, or 2x, 2 times x equals 132. So you could think of it as x plus x equals 132. They're perfectly balanced because I'm telling you they are what? Equal. But I need to isolate that x. And because this is multiplication, what's the opposite of multiplication? Division. So how am I going to isolate the x? I'm going to divide by 2. How do I show that in an equation? 2x divided by 2 equals 132 divided by 2. And that's going to equal 66. I've just divided 2 into 2, right? So that would give you 1, or we just cross those right out. Because you could think of this as 1x, right? But we don't need to write that 1. So it's just x equals 66 because 2 goes into 132 66 times. Now, if your brain doesn't like the way that looks, we can also do it a different way. We can multiply by the reciprocal of the coefficient. So if you want to think of whole numbers are really themselves over the number 1, right? So this could be like 2 over 1, x equals 132. What's the reciprocal? Half. So you would take 1/2 times 2, well, let's just put our little over 1, equals, remember, whatever I do to this side, I must do to the other side. So 1/2 times 132. So that leaves me with 1x, right? Because this goes into itself once. 1x, and I don't really even have to draw that 1. So x equals 132 divided by 2. Divide 2 into 132 and you get, ta-da, 166. Same answer, just a different looking equation. Either way is correct. I'm going to do a few of these for you. Oops, that is the wrong page. Hang on. Put that over there. All right, so here we have a fraction and it's being multiplied, so we're going to use the reciprocal and multiply because we're using the reciprocal. I know, it seems kind of weird. It's you know how when you divide, you flip it over and you multiply? Yeah, that's what we're doing. So I'm going to write my reciprocal first. So I have 4/3 times 3/4 x equals, now, this is my addition of I made the problem larger by doing this, right? So whatever I do on this side, what? You have to do on the other side. That's right, I have to do on the other side. So 9/10 times 4 over 3. Now, I've just gotten rid of this, so I've isolated my x. Can I cross cancel? Always ask yourself that. And, oh, this problem I can. 3 goes into itself once, 3 goes into 9 3 times, 2 can go into 4 twice, and 2 can go into 10 5 times. Now I'm going to multiply across. I'm going to get 6 over 5. I'm going to divide 5 into 6, make it a mixed number, which will be 1 1/5. So x equals 1 1/5. Okay? How about this? We have x plus 2.5 equals 7. Since it's addition, I'm going to use subtraction to isolate my x. So I'm going to write x plus 2.5 minus 2.5 equals 7 minus 2.5. So whatever I do to this side, I have to do to the other side. So now I've just gotten rid of 2.5. So on this side of my equal sign, I'm left with x. So x equals, well, what's 7 minus 2.5? Oh, I don't know. Let's write it. Ding, 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 da, 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 da. Huh, it's 4.5. All right? Now, let's say we don't believe, well, how can we possibly be sure that this is correct? Well, let's just stick this 4.5 in the place of that variable. Okay, let's go over here. 4.5 plus 2.5, will that equal 7? Drum roll, please. Da-da-da! It does. Okay? So we're just finding the value of x, and I'm saying the value of x is 4.5. You don't believe me? Stick that right there where the value of x was, or where x was. Okay, a couple more. 4w equals 132. Well, that means we're going to divide, right? Because this is multiply. So we're going to do the opposite. We're going to divide. So I'm going to have 4w divided by 4 equals 132 divided by 4. So I've just gotten rid of those 4, so I've isolated my w. And now all I have to do is the math. 4 goes into 132 how many times? Well, let's do it over here. 4 goes into 132 3 times. You get a 12. You get, oh, look at that. Nice, easy number. So w equals 33. Bam. 33. Now, what if I didn't believe that? Let's put 33 in place of that w. 33 times 4. Will that turn out to be 132? This is so exciting. Okay, 4 times 3 is 12. 4 times 3 is 12. Plus 1 is... we are so smart. I can hardly stand ourselves. All right. X plus 3/4 equals 5/6. It's an addition, so I'm going to use subtraction. So I'm going to write the problem. Oops, sorry about that. X plus 3/4 minus 3/4. Whatever I did to this side, I have to do to the other side of my equal sign. So that's 5/6 minus 3/4. Now, I've just isolated my x, right? Yes, yes, you have. Can I do this? Nope. I have to have common denominators, right? Because I'm subtracting. The least common denominator of 6 and 4 is going to be 12. So I'm just going to write my denominators right now. 12 minus something over 12. What did I multiply 6 by in order to get 12? You multiplied by 2. Oh, you're so smart. So I'm going to multiply 5 by 2. So that's going to be 10. What did I multiply 4 by to get 12? You multiplied by 3. Again, you are just geniuses, so I'm going to take 3 times 3, which is 9. Now, can I subtract? Yes, I can. So what was my variable? X. So x equals what? 1/12. Okay, 1/12. One more. Here we go. We have a fraction. 3/4 x equals 5/6. So instead of adding, we're doing a multiplication. And to multiply, we're really going to divide, which is actually what? Using the reciprocal to multiply. All right, so the reciprocal of 3/4 is 4/3 times 3/4. X equals 5/6 times which one did this? 4/3. Okay, so I'm going to have x equals something, right? Because I just isolated my x. Can I cross cancel? Yes, I can. 2 goes into 4 twice. 2 goes into 6 3 times. Now multiply across. I have 10 over 9. Improper. Divide that in there. It goes 1 and 1/9. So x equals 1 and 1/9. Okay, it's not really difficult. You just have to keep it straight in your brain. To help you keep things straight in your brain, I want you to write this down somewhere. Maybe we need to make math notebooks. Properties of equality. You need to know these. In addition, if A equals B, then A plus C equals B plus C. What? Think of this as, okay, if 2 equals 2, then 2 plus 1 equals 2 plus 1. Well, of course it does. See? Easy. In subtraction, if A equals B, then A minus C will equal B minus C. I don't believe you. All right, so let's say these are 2's again. 2 equals 2. How about 2 minus 1 equals 2 minus 1? Well, of course it does. We're getting so smart. In multiplication, if A equals B, then A times C will equal B times C. Let's change it up. Let's say these are 3's. Equal, right? 3 equals 3. 3 times 2 equals 3 times 2. Now, Mrs. Van Zalen, how do you know that this is this? Because it's C. So if this C is 2, then this C has to be 2. Now, division, if A equals B and if C is not equal to 0, then A divided by C equals B divided by C. So let's say A and B are 12. 12 equals 12. 12 divided by 3 equals 12 divided by 3, right? So they're not hard. You just have to know what they are. You just have to be able to see it and label it as, oh, that's a property of equality for addition. All right, there's no homework on this lesson, but again, if you do not have a clue about what I was just trying to teach you with this balanced scale and doing the same thing to one side of the equal side as you do to the other side of the equal sign, talk to me, because these are concepts we will be building on in future lessons. All righty, no homework for this part. See you later. Bye.